Okay, so this last part is the trickiest part. First of all, you have to make sure you know these two formulas for your test, and we're going to talk about these two things. When you go around a circle, there are two things that you have a speed or velocity. You have an angular speed and a linear speed, or an angular velocity and linear velocity. And the best example I can use to explain this to you is taking like a pair of keys on your finger and swinging them around and around. So if you were to swing something around and around, so here are my keys, or whatever it is, it's going to go around and around and around and around. The rate at which it spins, so at the center, the rate at which it spins around and around, that's the angular speed, how fast it rotates. The linear speed would be, let's say I have an object right here, this little X or star. The linear speed is that as they're spinning around, let's say the star gets up here, let's say that whatever this is flies off, just shoots off the circle. The linear speed is how fast it would shoot off the circle. So angular speed is how fast you spin, and linear speed would be how fast, if you were to like unfold the circle, how fast it would fly off. So to do number one, it says the second hand of a clock is 10.2 centimeters long. Find the linear speed of the tip of the second hand that passes around the clock. So we're going to do linear speed, which we know is V, equals S over T, and S is my arc length. So if you think about this, you have a circle, and the second hand we're going to say goes all the way out. It's 10.2 centimeters long. S is the arc length, and the second hand is going to go all the way around the circle. So you need to start thinking about arc length as circumference. I need to know the circumference of the circle, because that's the whole arc of the whole circle. So circumference of a circle is 2 pi r, so 2 pi times 10.2 inches. And the second hand goes around in seconds, so let's do this in 60 seconds. And this was, not inches, centimeters. So my arc length is right there of the whole circle, and that's the time right there. And so I'm just going to type it in my calculator. I literally am going to type 2 pi on top times 10.2. On the bottom I'm going to put 60. And it's going to tell you that your linear speed is 1.068, and you got to make sure you label it, and let me explain to you why. Centimeters per second. I agree that there's 60 seconds in a minute around the clock, and I use seconds because it told me about the second hand, but I easily down here could have done 1 minute, because 1 minute is equivalent to 60 seconds, and if you had put a 1 down here, your answer would have looked different, but your label would have been different as well, which makes the two answers mathematically equivalent. So it is super important that you label your answer. Okay, the next problem says that we're going to be on a Ferris wheel, and just make Ferris wheels your friend now because they're not going to go away at all this chapter. So a Ferris wheel has a 50-foot radius and it makes 1.5 revolutions per minute. Find the angular speed per minute. It says per minute. Okay, so this little funny letter is called omega, and we use it to talk about angular speed, and it's equal to the angle you rotate over the time you rotate. Okay, and so if I'm going to do this, the angle that I rotate is 1.5 revolutions. So the whole circle is 2 pi, so I'm going to do 2 pi times 1.5, because I'm going to make a circle and a half, and the time that I'm going to do this in, it says it makes 1.5 revolutions per minute, so 1 minute. This is going to get me 3 pi radians per minute. And I did radians because I used the 2 pi here. If you had done 360, you would have used degrees per minute. And then part 2 says to find the linear speed of the Ferris wheel. So V equals the arc length over time. I'm going to do it in minutes again because we did it in minutes up here. So my arc length is 2 pi r, so 2 pi times my 50-foot radius, but that's only for one circle. That's only if I were going to go around once. And then the time it takes me to do this is 1 minute, but you have to take into account that you didn't just go, in 1 minute you didn't just go one circle, you went a circle and a half. So in here, instead of using my 2 pi, I'm really going to use my 3 pi, or my 2 pi times the 1.5. So I have my 3 pi times 50 over 1 minute, so 150 pi, and this is going to be feet per minute. And if you want to multiply the pi in, you can.